Dear friends, our new topic is complex numbers. Before starting complex numbers, we shall learn on the imaginary numbers. Friends, the equation of the form x square minus 4 is equal to 0, you can get the solutions of this one because this is equal to square root of 4. Therefore, x is equal to plus minus 2. So you are getting two roots of x square minus 4 equal to 0. They are respectively 2 and minus 2. Now the important thing is when the equation is given this one, say x square plus 1 is equal to 0. Now what are the solutions of this quadratic equation? You see, this is x square is equal to minus 1. Therefore, x is equal to plus minus root over minus 1. Now what is this one? Root over minus 1. The equations of the form x square plus 1 is equal to 0 or x square plus 4 is equal to 0 etc. are not solvable in R. That is, there is no real number whose square is a negative real number. Euler was the first mathematician to introduce the symbol iota, for the square root of minus 1. That is a solution of x square plus 1 is equal to 0 with the property I square is equal to minus 1. He also called this symbol as the imaginary unit. So we write this symbol I square is equal to minus 1. This came from this one, I is equal to root over minus 1. Euler has first introduced this one. So when I square is equal to minus 1, what is I cubed? I cube is equal to I square into I. So this is equal to minus 1 into I. So this is minus I. So I cube is equal to minus I. Now what is I to the power 4? I to the power 4 is equal to I square into I square, that is minus 1 into minus 1, that is equal to 1. So I is equal to root over minus 1, I square is equal to minus 1, I cube is equal to minus I, and finally I to the power 4 is equal to 1. Now one interesting thing is, in order to compute I to the power n for n is greater than 4, we divide this n by 4 and obtain the remainder r. Let m be the quotient when n is divided by 4, then n is equal to, I can write this as 4m plus r, where 0 less than or equal to r less than 4. So I to the power n is equal to I to the power 4m plus r. So we can write I to the power 4 whole to the power m into I to the power r. And you know I to the power 4 is equal to 1. So put it here, 1 into I to the power r, that is equal to I to the power r. So I to the power n is equal to I to the power r. Now my question is, what is the value of I to the power 7? What is I to the power 7? So see, I to the power 7 is equal to, if you divide this 7 by 4, you will get 4 1 is 4 and the remainder is 3. So remainder 3, so this is I to the power 3. Now I to the power 3 is equal to minus 1. So this is minus I. So I to the power 7 is equal to minus I. Again I repeat, the Euler represented this one root over minus 1 as I. So I is equal to root over minus 1. I square is equal to minus 1. I cube is equal to minus I. I to the power 4 is equal to 1. So when n is equal to 4m plus r and you have to find out I to the power n, then this I to the power n is equal to I to the power 4m plus r. So I to the power n is equal to I to the power r. R is the remainder. So when you find I to the power 7, then you are actually finding I cube, and I cube is equal to minus I. Now one question to you friends, if I ask to find out I plus I square plus I cube plus I to the power 4, what is this value? This is also very simple, because I is as usual I square is equal to minus 1, I cube is equal to minus I to the power 4 is equal to plus 1. So I is cancelled, minus 1 plus 1 is also cancelled. This is equal to 0. Now can you tell me the important question, what will be this result? Root over minus 2 into root over minus 3. Will you write root over minus 2 into root over minus 3 is equal to minus 2 into minus 3? That is equal to root over of 6. No, this is a wrong statement. This is a wrong statement, because for any two real numbers a and b, the result root over a into root over b is equal to root over ab. This is true only when at least one of the given numbers is either 0 or positive. Now what we have provided you? This was root over minus 2 into root over minus 3. Both are negative. For these you can't write this as root over minus 2 into minus 3. So what to write? You have to write this as I into root over 2 into I into root over 3. So I into I means I square, and 2 and 3 both of them are positive. For this you can write 2 into 3. So I square is equal to minus 1 into root over of 6. So this is equal to minus root 6. So root over minus 2 into root over minus 3 is equal to minus root over 6, not only root over 6.